So hi everyone. So we're going to be doing the same problem as in the last video, but we're going to be using we're going to be using a different approach. Namely, I'm going to be using the derivatives and single variable calculus. So I'll call this product of signs on the left hand side f of x. So f of x is equal to sine of 2x times sine of 6x. I'm going to differentiate both sides with respect to x, of course, and that will give me that f prime of x is equal to, and we'll have to use the product rule, the derivative of the first one, which is cosine of 2x, and times the derivative of 2x, which is just 2 times the cosine of 2x, and times the first one, times the sine of 6x, plus the derivative of the second one, which is just 6 times the cosine of 6x times sine of 2x. Okay, and we'll have to set this derivative to be equal to 0, which will give us a rather usual trigonometric equation. So 2 times the cosine of 2x times the sine of 6x plus 6 times the cosine of 6x times the sine of 2x is equal to 0. Okay, now I'm going to go ahead and divide everything by 2. So here we're going to have just 1, and here we're going to be left with 3. Okay, so how can we solve this equation? Well, this would be a good time to transform these products of sines and cosines into sums or differences. So I'm just going to go ahead and say sine of alpha plus beta is equal to sine of alpha times sine of beta. Sine of alpha times cosine of beta plus sine of beta cosine of alpha. And sine of alpha minus beta is equal to sine of alpha cosine of beta minus sine of beta cosine of alpha. Okay, now I'm going to go ahead and add up these two equations. So that will give me that 2 times sine of alpha cosine of beta is equal to sine of alpha plus beta plus sine of alpha minus beta. And okay, I'm going to go ahead and use that and divide both sides by 2. And this will give me this final form. Now, that would mean that this first expression can be rewritten as 1/2 times the sine of 8x plus the sine of 6x minus 2x, which is the sine of 4x. And the second expression can be rewritten as plus 3 over 2 times sine of alpha, and alpha is 2x in this case, plus beta. So sine of 8x plus the sine of 2x minus 6x, which is the same as the sine of negative 4x. And this, of course, must be equal to 0. I'm going to multiply both sides by 2 to get rid of the parentheses and get rid of the parentheses. So sine of 8x plus sine of 4x plus 3 times the sine of 8x plus 3 times the sine of negative 4x is equal to 0. I'm going to go ahead and add up the like terms. So that will give me that 4 times the sine of 8x, and for this part, since sine is an odd function, sine of negative 4x is just the same as the negative sine of 4x. So 4 times the sine of 8x minus 2 times the sine of 4x is equal to 0. Now this is a lot more manageable. I'm going to go ahead and divide both sides by 2, which will give me that 2 times the sine of 8x minus the sine of 4x is equal to 0. And the sine of 8x can be rewritten as 2 times the sine of 4x times the cosine of 4x, which is, and times this 2, which we already had here. That is going to be 4 times the sine of 4x times the cosine of 4x minus the sine of 4x. And all of that is equal to 0. So sine of, I'm going to factor out the sine of 4x. So I'll put it in front. Sine of 4x times 4 times the cosine of 4x minus 1 is equal to 0. So I'm going to go ahead and solve that. In the first case, we get that 4x, that the sine of 4x is equal to 0. And from here, we get that 4x is equal to k times pi, where k is an integer. So x must be equal to k times pi over 4. That's one solution. And the other one is 4 times cosine of 4x minus 1 is equal to 0. So cosine of 4x is equal to 1 over 4. So 4x must be equal to the inverse cosine, or the arc cosine of 1 over 4, but it will have either a plus or a minus. Why? Because cosine is an even function. And of course, plus 2k pi, where k is an integer. So x is equal to plus or minus 1 over 4 times the arc cosine of 1 over 4 plus k times pi over 2. Okay. And now, so these are the solutions to the first derivative equation. And so now we're supposed to find out, and these are also the stationary points. So if we go ahead and let's just pick a single solution. So I'm going to say that k is equal to 0, and that will give us 1 over 4 times arc cosine of 1 over 4. Okay, and now we're supposed to find out whether this value will give us a maximum or a minimum extreme value. Okay, I'm not going to show you how to do that. I mean, you have to take the second derivative, plug this in. If it's less than 0, it's going to be a maximum. If it's more than 0, at this point it's going to be a minimum, etc. But I'll leave that up to you. In either case, I'm just going to go ahead and tell you that the function has a maximum value at this point, and you'll let me know why in the comments, I hope. And what you're supposed to do later is plug in this value into the original equation. Okay? So when you do that, you'll get that the maximum value is approximately 0.563, and that's the global maximum. There is no point in the real world where this function can have a value that's greater than approximately this. And it's supposed to be equal to 1, and we've just proved, and you'll show me the rest of the proof, why it can't be equal to 1. Okay. So that's the final answer to this video. This is, I'd say, a bit more complicated method, but it's a good calculus exercise. I hope you enjoyed the video, and as always, leave a like and subscribe. I'll see you in the next one.